Hi guys, today we'll be discussing and solving one of my favorite problems, designing an expense sharing app like Splitwise. If you have never heard of this app before, it's an app for friends and roommates to track bills and other shared expenses to stop stressing about who owes who and how much. Let me explain it to you with an example. There are four friends who live together in an apartment. Starting from the left, let's call them P1, P2, P3 and P4. P1 makes a transaction and pays the electricity bill of $800. This expense, when divided equally among all, makes the others owe him a sum of 200 each. So this expense gets added to their balance sheet. Then P4 makes a transaction of $400 for groceries and divides it among all of them. This makes others owe P4 $100 each. When this gets added to their account, the values update to reflect P2 and P3 owing a total of $300 each, P1 still not owing anything to anyone, and P4 now owes $100 in total as opposed to $200 before. So this is what Splitwise does, though more elegantly and with many more features. Now let's discuss a few terms before proceeding over to the requirements. First would be the split equally. This means splitting an expense equally among all, as we saw in the previous example. 4,000 split among 5 would be $800 per head. Then we have split exactly. This is used when a split is made between two or more other persons and you know the exact amount each of them should owe. In the example given, 4,000 is split exactly as 2,500 and 1,500 between two persons. We also have a split by percentage which divides the given value by percentage. This is a case where we know the measure of a user owing another by percent. If there are four friends living in an apartment where one of them has a master bedroom twice in size to that of the other person's, and so she decides to pay the rent twice as much as others, then their percentage share should be 40% for the master bedroom user and 20% for the rest three. In the given example on screen, a sum of 4,000 divided by percentage given would yield appropriate values owed by each user to the creditor. With the given terminologies, let's have a look at the application requirements. A user should be registered to be considered for involvement in expense calculation. This is fairly obvious given that the registration should include the user's details anyway. Expenses created should be of type exact, equal or percent only. In case of exact and percent, verify if the figures match the given total amount. This means in case of exact expense, we need to input the principal amount, the number of users, the amount should add up to the principal amount. In case of percent, the percent value should add up to 100. At any point of time, the application can print the total sum owed and the individual amounts owed to and by the user. Again, a mandatory feature since users should know the expense matrix before and after adding another expense. The final amount should be rounded off to 2 decimal places and the total should add up to the principal amount. Say we are dividing the amount 100 among 3 users. 2 of them should get 33.33 each and one of them 33.34. That way all adds up to 100 and there is a marginal or negligible difference in the amounts shared. Next, let's see how the class diagram would span out for such a system. First, we have the user class. Every user would have an ID to differentiate the user from the other users as we have been seeing in the previous designs. There would be a name field essential for showing the balance against. Then there would be a user expense sheet field which keeps track of the expenses between the current user and other users. Please notice that we have used a vector of pairs here. The pair data structure in C++ groups two values together. It can be thought of as a placeholder for the values. You may use a struct or another class if you like. In the snakes and ladders design problem, I have used a class to keep track of the start and end variables. If you wish, You can have a similar one here. The first value of the pair would be a user, which would be the user from which the current user owes or is owed. The second would be the amount, which would be double. We also have a total expense so far field, which contains the total amount borrowed or lent so far from all users. The function add to user expense sheet adds an expense to the expense sheet of the user. This can be the money borrowed or lent from other users. Finally, the getter for total expense so far, which returns the expense credited or debited so far. Then we have the expense class, which deals with the hoopla around expenses. This also has an ID, which uniquely identifies an expense. This is the first design in the series where we are having IDs for multiple classes or objects. We also have a field description to describe the expense. This is to gain additional information about the expense, but is strictly optional. In my opinion, if you are short on time, I would suggest skipping this temporarily and probably add it when you are ready with the complete design. And if you have quite some time after fulfilling the requirements, it would be a nice feature to have. Stuff like this takes you one step closer to take the demo to the real app. And so you may easily be awarded bonus points, giving you an edge over the competitors. Next we have the split feature, which is an enum and having values equal, exact and percent, as we'll see. Then we have the field percent distribution. This will have meaning only when the user chooses to split by percent. The user has to input the percent values to this field, which is a vector. Lastly, we have the exact distribution variable, which is equivalent of the percent distribution for the splitting exactly feature. Finally, we have the splitwise class, which exposes APIs for the user to leverage the splitwise features. It has the users variable, which contains track of all the registered users. Also has the user IDs, which is a set ensuring that duplicate users are not registered. This is more of an internal feature than a requirement. We have the calculate expenses function, which calculates the user expenses. A verify users function for verifying the fact that the users passed as a parameter for calculating the expenses have registered to the app. The register user function registers a user to the app if not already registered. And add expense feature to add an expense. Pretty straightforward. At last, we have the print balance for all users, which prints the balance sheet for all users out to the console. This is the most important feature of the app, for which the app was built on the very first hand. That completes our overview of the app design. Let's dig deeper into the cool stuff.